Hi, Sam Roberts here for Roberts Geospatial. So I made a video recently where I computed the area of Pakistan that was flooded in the 2022 flood event for the Indus Valley. I'm not 100% happy with the result that I got. So I've made some enhancements to my product, ProRaster Scientific, to make it easier to compute that kind of analysis. And I just want to show you what I've done. So here were the scenes that I was looking at. I have some Landsat data. So I have 8 scenes, and that covers the Indus Valley in the southern half of Pakistan. So the nature of this flood is that it comes from north down to south, and it was over several months. So if you look at a snapshot in time and compute the amount of land that is covered with water, that's not going to give you a valid result. You need to look at the flood as it moves over time and accumulate all of the pixels that are covered with water. Now I did that manually using calculator operations on my virtual rasters. And it struck me that doing that was such a useful technique that we should be able to do it much more easily. So I built the feature into the software. So let's just go to one tile. I'll just show you what you do. So if we go to these ones here, and I'll create a composited scene product. So I've got one scene, just one out of the 8. Now, normally what you would do is that you would order these scenes and you'd choose some kind of pixel masking. So we'll mask by for only clear pixels, so we'll remove all the cloud, and we'll order by acquisition date, latest or earliest to latest. Hit OK. So there's our scene. Let's just create a rendering algorithm for it. Something like this. We'll choose shortwave infrared. Open that in ProRaster. Put that over there. So there's our scene, and you can see the water in that scene as this sort of bluer colour. So going back to my properties on my composited scene. So the new feature here is the retention rule. So if you drop this down, you'll see a list. Firstly, you can retain pixels by the order. So this is how we did it before. Usually you're ordering them so that you get pixels that are closest to the acquisition date that you're interested in, and you're going to mask out the pixels that contain cloud. So now we have some other options. So I have 4 statistical options. So you can choose the median value, the mean value, the maximum or the minimum value. Now when you do that, the order of the scenes becomes irrelevant, so you don't need to worry about the order at all. It's just going to look at all the scenes and it's going to compute, for example, the median value. So which ones of these are useful? Well, median is definitely useful, and that's the technique that you'll use when you're doing reduction in Google Earth Engine, for example. So if you have scenes where the majority of pixels are cloud-free, then the median value will be within the cloud-free pixels. And you can improve that, of course, by masking out your cloud so that you're more likely to get a good value. The mean value is probably not as useful, but if you're masking out your cloud, then it's probably still a reasonable method to use. Minimum and maximum value, I'm not sure if they are useful. I mean, you probably, in some instances, you'll want a minimum or maximum value from certain spectral bands, but that won't be applicable to other spectral bands. So I'm not sure if they are particularly useful options. The final option is by computed value, and that's what we're going to use here. So hit by computed value. Now, what happens is, for each scene in the composited scene or composited mosaic, it's going to create a another virtual raster, which will apply some kind of calculator expression to compute a value for all the pixels in that scene. And then I'm going to retain the scene pixel value that has either the maximum or the minimum computed value, or that value is closest to a target value, which I then specify here. So it might be 100, for example. And the calculator expression at the moment is set by choosing a spectral index. So in this case, we have a flood. We have scenes that have been acquired over a period of about 6 months, and we want to choose pixels where the water is most likely in each of those pixels, so that we're tracking the water as it goes down the valley. So let's choose the NDWI water index as our formula, and then I'm going to choose the maximum value of that water index and hit OK. Now again, with when you're using this computed rule, the order of the scenes is immaterial because it's going to consider each scene independently. And you can either mask or you can turn masking off if you prefer, but we'll keep masking on. Hit OK, and then you can see here that we now have quite a lot of blue in our scene. So we're retaining all of these pixels that have got water in them. And so you can see the extent of this flood event. It's gone all the way out here, it's flooded down here, it's flooded down the river, and we're keeping all those flooded pixels. If we go to the minimum, so now we're rejecting pixels that have a lot of water in them. Look at the scene again, and you can see that this time we've retained vegetation. So we're not seeing very much water at all, and we're seeing a lot more vegetation. So I went back to I should just mention one other thing. Well, okay, so I went and downloaded all of the data for these 8 scenes over that period. All of the Landsat data, whether it was cloudy or not, put it all together, and use this technique to select the pixels that are most likely to have water in them over that period of several months over which the flood was occurring. I masked by cloud. I computed NDWI. I kept any pixels that were greater than 0 for that index. I clipped it to a polygon for Pakistan, took out the offshore areas and so forth, and then computed statistics, and that gave me the area of flooded ground. The only other thing that I want to mention is that some of the scenes that were downloaded over that period were unusable. So the USGS, in their processing, for reasons that I can't explain, have got the processing wrong for cloud recognition. So they have not classified the pixels appropriately with their QA data, and they haven't identified cloud where it's clearly cloud in the imagery. Sometimes it's misclassified as snow and ice. Otherwise, and sometimes it's not classified as cloud or snow or ice at all. Those scenes were unusable, and so I excluded those from the analysis, and I put in a feature in the software where you can actually tag scenes as being unusable. So this scene here, for example, that's red in my spreadsheet, I've identified that as a bad scene. I right-click on it and I say set quality tag to unusable, and thereafter it will not be used in any processing. So when you create a product with the wizard or manually, if that scene is a part of the collection that you're processing, it won't get used. So I took that bad data out and then computed statistics and came up with a final number. So my flooded area was 30,986 square kilometres. I then went to the year previous and did the same exercise in order to remove standing water, so like lakes, the river channel itself, irrigation channels are part of the statistics. So that removed 3,264 square kilometres. My final flooded area was 27,772 square kilometres, which excludes those areas that would normally be covered with water anyway. So I think that's probably still an underestimate, but I don't think that we're very far away from a good value. So comparing that to some of the other values, they were from 6,000 square kilometres right up to 75,000 square kilometres. I think the 75,000 is out by a factor of 2 or 3. I think the 6,000 is out by a factor of 4 or 5. And so, you know, the value that we've got now of 27,772, probably an underestimate, but very close to the real number. And so I just wanted to show you that, and that is a technique that you can use in your own analysis. Of course, you don't have to look for water. You could use a vegetation index, for example, and look for the most amount of vegetation in order to do some kind of statistical analysis or whatever it is, the project that you're working on. So thanks for watching. That's ProRaster Scientific, which you can purchase on the Microsoft Store.